Alright, hello everyone. So this is going to be a pretty short video. This is just a follow-up of the previous one on calculating the pH of an acid. So we're going to talk about the pH of a base here. And I just have the formulas for common bases here. So we have sodium hydroxide, potassium hydroxide, barium hydroxide. So there's a theme here. But there's some other bases that do not contain the hydroxide ions, and we're not going to concern ourselves with how to calculate the pH for those bases this year, or ever really. So we're just going to focus on the hydroxide based bases. Wow, that sounds bad. All right, just a recap. Bases are generally proton acceptors, and most bases contain a hydroxide groups in the formulas. But the interesting thing is that they don't have hydrogen ions. So, how can you calculate the pH if there's no hydrogen? So that you how can you find the concentration of hydrogen if hydrogen is not there? So, negative log to the base 10 of concentration of hydrogen ion is the definition of pH. So, how would we calculate the pH for a base? I think one of the other things that's probably worth noting is that bases are ionic compounds that fully dissociate in water. So if I have NaOH in water, it will fully dissociate into Na plus and OH minus. So that's a full dissociation, which means that if I have 10 molecules of NaOH, then all 10 will turn into sodium ions and hydroxide ions. So that's what full dissociation would mean. So in order to calculate the pH of a base and to sort of get around the fact that there isn't any hydrogen, so you can't really determine the concentration of hydrogen ions, what we're going to do is we're going to calculate POH because there's hydroxide ions present, or PO as some my old chem teacher said, not to be confused with one of the MasterChef finalists. So POH stands for power of hydroxide ions, and the way that you calculate POH would be the same way that you would calculate pH. So POH would be negative log to the base 10 of the molar concentration of hydroxide. And if you start with concentration of hydroxide, you can go 10 to the negative POH, will allow you to go backwards. So this is exactly the same as pH. It's just that you replaced hydrogen with hydroxide. So square brackets OH minus denotes the concentration of hydroxide ions in mole per liter. And if you have a very low POH, then you have a lot of hydroxide ions present, and that indicates a very, very basic solution. So POH is not commonly used, but it is a thing that you can use. It's just a little bit confusing if there's a pH and then POH. So still, we need to try to find a way to combine those two scales into a single one. And this is how you would do that. Now, this formula only works at 25 degrees Celsius, but we are going to assume everything is at 25 degrees Celsius. But essentially, the pH of a solution, or pH plus POH equals to 14, and this is a constant. So if I want to find the pH of a base, then what I would need to do is I need to find the POH, and then I just need 14 subtract that, and that will give me the pH. Now, if you're very good at log laws, which who can claim that they are, you can work this out yourself, but this is not math, so I'm just going to tell you what it is. If you have the molar concentration of hydrogen and the molar concentration of hydroxide and you multiply them together, that should equal to 10 to the power of negative 14 as well. And this is also a constant. So if I want to find the concentration of hydrogen ions, I can just take 10 to the power of negative 14 divided by the concentration of hydroxide ions. Okay, so this is just maths. So you can see here, these are the pH and POH scales. So they run like opposite of each other. Just to make life simple, especially for the layperson, we usually just look at pH, but you can really rewrite the script of society and just use a POH as the more popular version. So you do need to remember these two formulas, or really at least the first one, and then you should be able to calculate the pH of a base from that. I have a couple of examples here of how to do that. So calculate the pH. I don't know why I keep giving you the volume. You really do not need it. So the volume is 100 ml. The concentration of the base, so sodium hydroxide, is 0.15 molar. So just keep in mind the two formulas that we can use for calculating pH via for a base. The first one is pH plus POH equal to 14. And the second one is molar concentration of hydrogen multiplied with molar concentration of hydroxide equals 10 to the power negative 14. So I'm going to show you how you can use each of the formulas. You don't only need one. So these are just two different methods to arrive at the same answer. So for that, I'm going to use the first formula, which means that if I want to find pH, what I need to do is I need 14 minus the POH. So I'm going to find POH first. And POH can be calculated the same way that you would calculate pH. So I need to find the molar concentration of hydroxide ions. Now, if you look at the formula, you can see that there is one hydroxide ion for every sodium hydroxide. I'm just going to use a square bracket because it's molar concentration. So the molar concentration of hydroxide ion would equal to the molar concentration of sodium hydroxide in this case, because if you look at the formula, the ratio between the two substances is 1 to 1. So the molar concentration of OH minus is also 0.15 molar. So I can find POH, which is negative log to the base 10 of 0.15. Use a calculator. I totally cannot do this by hand anyway. So I get 0.824 as the POH. So pH is going to be 14 minus POH, which is 14 minus 0.824. So I have 13.18, and this is my pH, which makes sense because this is a base, so you should have a pH of above 7, and this is a fairly strong base, so it's quite close to 14. So this is the first way to calculate pH of a base using this identity of pH plus POH equals to 14. I'm going to go to the second method. You take your pick. I mean, they work out the same way. So second part still asks for pH. Volume is 100 ml, which totally do not need. And the molar concentration of the base is given. The base is barium hydroxide in this case, which is 0.25. Okay, so the second formula is a relationship between molar concentration of hydrogen ions and hydroxide ions. And because I want to find pH, I need to find the concentration of hydrogen ion if I don't want to go through POH. So in order to do that, I just need to find the concentration of hydroxide and then go 10 to the power negative 14 divided by that. And then I can go from there. So let's have a look at this formula. Barium hydroxide, there's a 2 here. So for every barium hydroxide substance, there will be twice the amount in hydroxide ions. So the concentration of hydroxide ion is actually going to be twice the concentration of barium hydroxide in this case. So we're going with 2 times 0.25, which is 0.50, okay? And because now I have the concentration of hydroxide, I can work out the concentration of hydrogen ions, which is 10 to the power negative 14 divided by 0.5, which equals something. 2 times 10 to the power negative 14. Oh my god. You know, I totally could have done that by hand. Well, that is very embarrassing. Anyway, it's late and my brain is not working, so that's my excuse. So pH is now negative log to the base 10 of the molar concentration of hydrogen, which is negative log to the base 10 of 2 times 10 to the power negative 14. And then, well, that I definitely can't do by hand, even if I wanted to. So I get 13 point, let's go with 70. So again, it makes sense. It is basic. Use your common sense. If the question asks for the pH of a base and your answer is 2, you probably have done something wrong. All right, so those are the 2 examples. There are 3 questions for you to practice on that I encourage you to do. So these are the last 3 questions of the acid-base pH calculation worksheet. Now the last bit here is just really well, you do need to know the theory behind the number 14 and why is it that we can link pH and POH. And the reason for that is because of a process called self-ionization of water. I told you, water is amazing. So as I'm sure you may recall, water is an amphiprotic species. Doesn't mean that it's a frog. It means that it can act as both an acid and a base. And it is a pretty weak acid and base. I guess every amphiprotic species is probably quite weak. If it can do both, then it's probably not very strong in either of the areas. So it's one of those jack of all trades, master of none type of situation. So water can weakly donate and accept hydrogen ions by itself. So if you have a water molecule or two water molecules, one of them can go and give a proton or a hydrogen ion to the other. So one of them is going to have, I suppose, if you want to match it, let's say this one's going to give the hydrogen ion to the other. So there will be a hydronium ion and a hydroxide ion being formed as the result of that. Now, if you simplify the process, then you just have H2O can self-ionize. Well, it can self-ionize into hydrogen ions and hydroxide ions. So if you will, there is hydrogen ions present in water, just a very, very small amount. Water is considered neutral because the concentration of hydrogen ions and hydroxide ions would be the same in water. So the definition of neutrality is actually not pH of 7. Definition of neutrality is you have the same concentrations of hydrogen ions and hydroxide ions. Now, the interesting thing about water is that the product, or if you multiply the molar concentrations of hydrogen and hydroxide together, it will give you a constant. And this constant is called the ionization constant of water. So at different temperatures, these constants take different values. It's just that at 25 degrees Celsius, if you take the molar concentration of hydrogen ions and hydroxide ions and multiply them together, the product would equal to 10 to the power of negative 14. There's an entire chapter in year 12 that talks about what this actually is, but for now, you just need to know that you multiply the two concentrations together, they equal to 10 to the power of negative 14. And because we already know that for water, the concentration of hydrogen ions have to equal to the concentration of hydroxide ions, and if they equal to each other and they multiply together to 10 to the negative 14, then each of them will equal to 10 to the power of negative 7, which is another way of saying that pH of water is 7. Okay, so if I have another way of writing this is pH plus POH equal to 14. So this is just a direct consequence of the self-ionization of water. I would say for the most part, you just need to remember this. The fact that the concentration of hydrogen and hydroxide is equal to 10 to the power negative 14, as well as the fact that pH plus POH equals to 14. But if the product equals to 10 to the power negative 14, and then in the case of water, since the concentrations of the two species are equal to each other, each of them will just be 7. So that's something to remember. And that's it for this video.